All right, we're on 9.5 P164. We did 163 on the previous video. That was the front side, and now we're on to the back side, P164. All right, let's get right to it. Number one, 4 friends earned $5.20 for washing the car. They shared the money equally. If they're sharing equally, I know I'm going to be dividing. And the same thing as division is repeated subtraction, so either one. How much did each friend get? Well, let's draw the 4 friends. We don't know their names, so we'll just say friend 1, friend 2, friend 3, and friend 4. And we are sharing $5.20, so again, I can model that. Here's $1, $1, $1, $1, that's $4, $5, and then 20 cents. Well, I know the shortcut. I could make it 2 dimes, but I'm going to notice real quick that there's 4 friends here. So I'm going to break that 20 cents into nickels because I know 4 nickels makes 20 cents. So if you see little easy shortcuts like that, don't hesitate to use them. Okay, so 5 cents plus another 5 cents, that's 10 cents. I need 20 more cents, so another 5 cents is 15 cents, and another 5 cents would be 20 cents. All right, let's start sharing the money out. So the first friend gets that first dollar, so that dollar's gone. The next friend gets the next dollar. Sorry about that. So this dollar's gone. The next friend gets that dollar. So that dollar's gone. The next friend gets that dollar, right? We're just sharing it out. Dividing is when you're sharing things out. You divide them amongst your friends. Okay, we have $1 to split between 4 people. We can't rip the dollar, obviously. So let's change it out. And again, I can notice very easily. I have 4 friends, and I know 4 quarters makes $1. So I'm going to change that dollar out for 4 quarters. There's 1 quarter. 2 quarters, 3 quarters, and 4 quarters. And let's start sharing those quarters out. So friend 1 gets a quarter, friend 2 gets a quarter. Oh, sorry. So those 2 quarters are gone. Friend 3 gets that quarter. That quarter's gone. Friend 4, sorry about that. Keep. And represent. Okay. And friend 4 gets that quarter. So this quarter's gone. I don't know why that won't erase, but this quarter is gone. Okay, and now we'll divide out our 4 nickels. Each friend is going to get a nickel. So that nickel's gone. I don't know why it's not letting me. Oh, probably because I wrote them before I almost exited out of the whole thing. So that nickel's gone, and share that nickel. So that nickel's gone, and our last nickel. So that nickel's gone. Apologize. All right, that nickel's gone. Okay, so how much did each friend get? So now we need to look at, well, they all have the same, so we can look at any one of the friends to see how much they have. $1 plus a quarter plus a nickel. 1 plus 25 cents plus 5 cents would be 30 cents. So $1.30. Okay. Write a decimal that represents the value of 1 $1 bill and 5 quarters. Okay. Well, we know each quarter is worth 25 cents. Okay, and $1 is worth obviously 1 whole dollar. So I line up those decimals and I add those up. 5 plus 5 plus 5 plus 5 plus 5, or 5 times 5 is 25. 2 plus, or 2 6 times, if I want to use the multiplication shortcut, or I could just add them all. But 2, 4, 6, 8, 10, 12. carrying my 1. 1 plus 1 is 2. My decimal goes straight down. Line those decimals right up. So the decimal would be 2.25, or we would say that as 2 and 2500ths. Wherever you see the decimal, you can say that word and. 2 and 2500ths. All right, moving on. Number 3, Bethenny has 9 pennies. What fraction of a dollar does this make? Well, again, we have to remember a dollar is broken up into how many pieces? Well, a dollar can be broken up into 100 pieces, right? 100 pennies would equal a dollar. So as a fraction, we have a denominator of 100, and Bethenny has 9 pennies, so 9 hundredths. Number 4, Michael made 9/12 of his free throws at practice. What is 9/12 in simplest form? So we need a fraction that's equal to 9/12, but is in simplest form. So we need to find the greatest common factor, or the GCF, for the numerator 9, and the denominator 12. So I pull out 9, I pull out 12, and I find the factors. So factors are just the numbers you can multiply together to get that particular number. So I can do 1 times 9 will give me 9. And 3 times 3 will give me 9. And when you're listing factors, if you have a double like 3 times 3, you'll need to list the 3 once. Okay, to get 12, I can do 1 times 12. I can do, oh my goodness, I apologize, 2 times 6. I could do 3 times 4, and that's it. All right, now I want the greatest common factor, so between these two I want to find the biggest number that they have in common. Obviously they have a 1 in common. They have a 9 in common, no. 3, yes, 3 they have in common, and that's the biggest number they have in common. And I do this, that GCF step, I do this step because that 3 tells me what I'm going to divide the numerator and the denominator by. This 3 tells me what I'm going to do my division by. Okay, so 9 divided by 3 is 3. 12 divided by 3 is 4. So 3/4. Okay, number 5. I am a prime number, so that means it has exactly 2 factors. If it's prime, 2 factors. 1 and the number itself. Whoops. Ugh. I'm having trouble today. All right. I'm a prime number between 30 and 40. What number could I be? Okay, so between 30 and 40, well, what about 31? Let's see if 31 is prime. In order to do that, we have to factor 31. So what can I multiply together to get 31? Well, obviously, I can do 1 times 31. But can I do 2 times anything? Well, I see in the ones place, in order for 2 to be a factor, I need to have 0, 2, 4, 6, or 8 in the ones place. I don't have 0, 2, 4, 6 in the ones place. I have a 1 in the ones place. So 2 won't work. What about 3? Well, our divisibility rule says that if we take the 2 digits and add them, so 3 for the 3 tens and a 1 for the 1 1, if I take the 2 digits and add them, then that sum has to be divisible by 3. Well, I know 3 can't go into 4 evenly, so I know 3 isn't a factor. What about 4? Well, again, I could count by 4s. I know 4 times 5 is 20. Add another 4 would be 24. Add another 4 would be 28. Add another 4 would be 32. Close, but no cigar. What about 5? Would 5 work? 5, 10, 15, 20, 25, 30. Close again, but the next one would be 35. So we can continue to go through. You can check all those numbers, and we're going to find that 31 could be the answer. Now, there could be more than one, but it just said what number could I be? Well, this is one possible answer. Okay? As long as you choose a number that's between 30 and 40 and it is prime, there are other correct answers as well. Number 6, fill in the blank with a symbol that makes this statement true. 2/5 and 1/2. So if I want to prove this mathematically, I want to pull out those two denominators, 5 and 2, because I have different denominators, so that makes it a little bit harder to compare the fractions. But if I give them the same denominators, equivalent fractions with the same denominators, I can compare easily. So I'm going to find the multiples. I'm looking for the LCM, the least common multiple. And remember the difference between factors and multiples. Multiples are many. We can have as many as we want because they're counting numbers. So 5, 10, 15, I could go on forever. 2, 4, 6, 8, 10. I'm going to stop there. And this time, though, I want the smallest number they have in common. Okay, so 5 is the smallest number here. Is there a 5 here? No. Okay, the next smallest number is 10 up here. Is there a 10 down here? Yes. So 10 is the least common multiple. So I want to change 2/5, so it has a denominator of 10, and I want to change the 1/2, so it has a denominator of 10. And it'll be a lot easier for me to compare the two numbers. Okay, so 5 times what is going to give me that 10? Well, if we know our fact families, we can see 5 times 2. Whatever I multiply the bottom by, I multiply the top by the same thing. 4/10. So 2/5, this number here is equivalent to 4/10. And then up here, 2 times what gives me 10? Well, this is actually the same fact family we did down here. So 2 times 5, and then whatever I multiply the denominator by, I multiply the numerator by the same thing. You get 5/10. So 1/2 is equivalent to 5/10. And now we can very easily see 4/10 or 2/5 is definitely less than 5/10 or 1/2. All right, thanks again for watching, and I'll see you on the next video.